Coming to the fifth session of design of shaft, unit 3. Here we will study the simple problems on a shaft based on bending moment and simple problems on propeller shaft along with MCQ. First of all, we will study the problems on shaft based on bending moment. Basically, the shaft is acted upon two strength. One is shear as well as by bending. In the third and fourth session already we have done some problems on the basis of torsion. So today we will study a few problems on propeller shaft and a problem on a bending moment. The first question is: a pair of wheel of a railway wagon carries a load of 50 kN on each axle box acting at a distance of 100 mm outside the wheelbase. The gauge of the rail is 1.4 meter. Find the diameter of the axle between the wheels if the stress is not to exceed 100 megapascal. Write down the given data. The data is like this. That is, load is given. You can take it as W or F or P also. Here I have taken W, that is 50 kilonewton, and it becomes 50 into 10 raised to 3 Newton. This kilo has been converted in terms of 1000. Length of the wheelbase is given. That is, the length of the wheelbase is mentioned as 100 mm from outside to the axle box. That is, a axle box is provided to fix the axle. From there to its outside the wheelbase is 100 mm, and the gauge is for rail where the wheels will move on the rail is 1.4 meter. It has been given. Find the diameter of the axle. That is the diameter. What is the diameter of axle between the wheels if the stress is not to exceed, that is, bending stress is not to exceed 100 megapascal. While designing the diameter of the shaft on the basis of bending, we have to use bending equation, and the bending equation is given as M by I is equal to FB by Y is equal to E by R. Here we have to take only two fractions. Here three parts of fractions are there. M by I is one fraction, FB by Y is another fraction, and E by R is a third fraction. Here we have to take the two fractions. M by I is equal to FB by Y, because bending is given, and by the help of the inertia and bending moment we can have the diameter, that is the dimension. This shaft act as a overhanging beam, so we can have maximum bending moment at the axle box length, which has been mentioned as 100 mm from outside the wheelbase, and multiplying that length by load we can have maximum bending moment, which is nothing but M is equal to WL. W is 50 into 10 raised to 3 into 100 length, that is the distance between wheelbase outside to axle. So when you multiply these two, we get 5 into 10 raised to 6 Newton mm. After getting M, we will just substitute the equation I. I is equal to inertia, because it is a circular one. inertia for circular shafts is given by pi d 4 by 64, that is the standard value. By that value I just multiplied with FB. I is multiplied here, pi d 4 by 64, and y is the diameter's half, means it is a radius. It is nothing but the neutral axis to the distance between the neutral axis to extreme fiber. So it is d by 2, and I substitute the value in the moment equation. D will cancels with d4 and 2 will cancels with 64 to get to give 32. Therefore the equation which was initially uh, m by I is equal to fb by y has been changed to m is equal to pi by 32 into d cube into fb. Now I want to calculate d cube. D cube is nothing but 32 m by pi fb. Just substitute the value of m and fb. We will have the answer 32 into 5 into 10 raised to 6 divided by pi into 100. That is megapascal, given in this problem as 100 megapascal for fb. Substituting the value, I have d cube is equal to 509090.90. Then finally d is equal to 79.84 mm. Then from standard table 3.5a, and the standard value of the diameter of the shaft is 80 mm. This is the problem on bending equation for the shaft. So let us do some problems on a propeller shaft. An automobile engine develops 28 kilowatt at 1500 rpm and its bottom gear ratio is 3.06. If the propeller shaft of a 40 mm outside diameter is to be used, determine the inside diameter of the mild steel tube with the safe shear stress as 55 Newton per mm square for mild steel. That is the problem. Write down the datas. Datas is like this. P is equal to 28 kilowatt, that is power. N is equal to 150 rpm. Gear ratio is given 3.06, that is the bottom gear ratio. D naught is given 40 mm. D I have to calculate. Tau is given. Once again, this problem is on a shaft with hollow. So, and stress is given, that is shear stress. So we have to do this problem on the basis of strength only. I know the formula for tau. Tau is equal to 16t by pi d naught cube into 1 by 1 minus k4. So I have to calculate first of all what is T, torque. So the torque is obtained here is by the formula 9.55 into 10 raised to 6 P by N, that is equation number 3.3a of design data handbook. Or you can do by the power equation, P is equal to 2 pi N T by 60,000, where T is equal to P into 60,000 by 2 pi N. I'll substitute the value 28 kilowatt for P and N for power. N is equal to 1500 rpm. We will have the answer T engine. Now it is T, not T, it is a torque of the engine. Clear? And its value is 178.26 into 10 raised to 3 Newton mm. So this is the torque obtained for an engine. So propeller shaft, actually we are designing for propeller shaft. So this torque engine has to be shifted through the gearbox. So the torque transmitted by the propeller shaft is obtained with the help of the gear ratio, and it is given by torque of the propeller shaft is equal to torque on the engine into gearbox ratio, that is bottom gear ratio. So when you multiply, you will have 54549.6.01 or 5.49 into 10 raised to 3 Newton mm. So after getting torque of the propeller shaft, this torque to be adopted in the equation 3.1 of a data handbook for hollow shaft. When you use this, you come across in this manner: Tp is equal to pi by 16 into d naught 4 minus di 4 by d naught into tau, and because tau is equal to this way and k is nothing but di by d naught, I just change the value of k, because as mentioned d naught is not k. That's why we have taken di and d naught form that will be changes into this manner. That is pi by 16 into d naught 4 minus di 4 by d naught into tau. While substituting all the values, we will come across di is unknown, which can be calculated in this fashion. 40 or 4 minus di 4 is equal to 16 into 40 into 545496.01 whole divided by pi into 55. The answer is 2019687.70. Finally, I have di 4 is equal to 540312.3 and di 27.11. Coming to equation problem number 2. Design a propeller shaft for a double engine developing 30 kilowatt at 1500 rpm. The bottom gear ratio being 3.2 and the ratio external diameter propeller shaft and its inner diameter is 1.8. Assume a CF shear stress of 54 Newton per mm square for the material. Write the data. P is equal to 30 kilowatt N 1500 rpm, bottom gear ratio 3.2 and d naught by di is equal to 1.8. Then d naught is equal to 1.8 times di and tau is equal to 54. So once again I have to calculate the torque first, because tau is given by 16t by pi d naught cube into 1 by 1 minus k4 and k is equal to di by d naught. Torque of the propeller shaft to be calculated. So to calculate torque of the propeller shaft, I have to go back to the equation 3.3a, that is torque equation in the data handbook. D is 9.55 into 10 raised to 6 into P by N. So while substituting the value, substitute the value of P and N, I can have the torque of the engine 191,000 Newton mm. Then I calculate torque on P, that is propeller shaft, is given by torque of the engine into bottom gear ratio. When I multiply gear ratio with the torque of the engine, I have the answer 611,200 Newton mm for torque propeller shaft. After getting torque propeller shaft, I just substitute the values here. That is d naught cube equal to 16 into Tp by pi into tau into 1 by 1 minus k4. K is nothing but di by 1.8 di. The value will be 0.56 for k. So substituting the value 16 into 611.2 into 10 raised to 3 pi into 54 into 1 by 1 minus 0.5644. I have the value d naught cube is equal to 63.93 into 10 raised to 3 and d naught is equal to 39.99 mm, which is approximately 40 mm. Then di is equal to 22.2 mm. Thus the dimension for hollow shaft is 6. D naught 40 mm and di 22.2 mm. The third problem is design a propeller shaft for an automobile engine developing 33.5 kilowatt at 1500, given that bottom gear ratio 4, ratio of the external and internal diameter of the propeller shaft is 1.8, safe shear stress for the blade 58.8 megapascal, which is equal to 58.8 Newton per mm square. Write down the given data. Power is given 33.5 kilowatt and is given 1500 rpm. Bottom gear ratio 4, dA naught by di 1.8 and tau is 58.8. Substitute the values to get torque first. Torque of the engine can be obtained 9.55 into 10 raised to 6 into 33.5 by 1500. From this I can have the answer for torque of the engine, that is 2.13 2 into 10 raised to 5 Newton mm, or 213.18 into 10 raised to 3 Newton mm. So after getting the engine torque, I have to calculate propeller shaft torque, which is given by T into gear ratio 213,283 into 4. When I multiply, I have 85313 and 2 Newton mm. After getting the torque of the propeller shaft, just substitute in this equation for torque is equal to 16T by pi d naught cube into 1 by 1 minus k4, so that I can have d naught cube is equal to 81.95 into 10 raised to 3. Therefore d naught is equal to 43.44 mm. From this, di is equal to 24.4 mm. So that completes our session, and we will have few MCQs. That is first MCQ: propeller shaft is connected between universal joint along with a sliding joint. True or false? It is true. Propeller shaft must be light and well balanced so that the vibration will occur at high speed. The answer is B, that is false. Bending equation to find the diameter of the shaft is given by M is equal to I into sigma by Y. Torque transmitted through propeller shaft is given by B and C only, that is engine torque into gear ratio and engine torque into overall ratio. So few problems are given, just go through the problems and do it and completely work on this so that you can understand clearly everything. We do a few more problems on this basis so that you can come to know that what other problems may be asked in the exams. Thank you.